Oh, okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today, welcome to our final presentation of our System Modeling Big Project 2025. Uh, we are from Group 3. We are Group 3, right? We will present our big project today. That will be the first slide will be delivered by Fahmi.
Okay. Good day. This is the System Modeling Big Project from FRI 145. So the case study is about uh, Nordic Forest Company, an NFC, and the goal is to optimize the NFC's daily production schedule using system modeling. I'm Muhammad Fahmi, and yeah.
I'm Sasya Zari Kirana Putri.
And I am Nadia Kunanti.
Oke,
Okay, you can read the summary.
lanjut ya, bentar.
Yes, problem
Oke,
summary, please.
okay. So the problem summary from this case study is that NFC operates two forests, and they basically have the ability to turn logs from those forests to become uh, products by sending the logs into a sawmill, a pulp mill, or to make a profit by exporting it to another country. The goal of this case study is to find the optimal daily log allocation to maximize profit, with the constraints being uh, capacity limits, production demand, production cost, and pulp contracts. So this is the influence diagram that we have come up with. As you can see in the picture of the diagram, the bottom right has the output net profit, and it is connected directly to total revenue from exports, construction, timber, processed wood, and pulp. As you can see on the left of the slide, the control input is X21 S and X22S, meaning the logs to sawmill, and similar variables for pulp mill and for export. The uncontrollable inputs are the sawmill capacity and the pulp mill capacity, uh, and minimum and maximum demand, production prices, processing costs, and fixed costs. The system variables in this case is the product output, timber, dress timber, pulp export, and processing costs, total revenue. And as seen earlier, the output is the net profit, which is the one we're seeking to maximize.
This slide, this is a influence diagram explanation. The first is why X is a process variable because X is log allocation from forests directly determine which process the logs go through, like sawmill, pulp. Then why X includes other system variables in it. So for example, X21S and X22S, the logs to sawmill generate construction timber, dress timber, and wood residues, which then become inputs. And then why X generate revenue and incur process costs, which together determine the net profit Z. So X indirectly affects Z through the production and financial system variables. We can go to the next slide. This one is mathematical formulation. As you can see, the decision variable, it includes export, sawmill, and pulp mill. And objective function is we are maximize is equal to total revenue minus total cost. And then constraint, we have four kinds of constraints, as you can see here. And we can go to the next slide. And And this one is model and diagram connection. The first is variables in the diagram is equal to variables in the math model. The second one is input, process, output is consistent between diagram and model. And the third is sawmill outputs becomes pulp mill input scraps. And the last one is capacity and demand limits in the diagram appears as constraints in the model. And the next slide will be delivered by Sasi.
Okay, so Okay, so in here, let's move on to the optimal solution. So now, based on our result, the best allocation of logs per day is as follow. The first one is sawmill. For the F1, F2 is 30 cubic meters from forest 1 and from forest 2. And the second one is pulp mill. There's is the value of F1 and F2 is 20 cubic meters per day. And for the export timber is 50 cubic meter per day. And this allocation meets all given constraints. The sawmill operates exactly within the 6-hour capacity, and the pulp contract requirement of 60 tons in fulfilled, and export volume is maximized to generate extra revenue. So with the configuration, we ensure that each facility is working at its maximum efficiency. And for the result analysis slide, the result of the model show a clear balance between operational efficiency and profitability. So our facilities are fully utilized and our production and contract constraint are satisfied, and most importantly, the net profit is maximized. Here are the financial highlight. The first one is the revenue is 57,000 200, and then for the cost is 26,880, and the profit is 30,320. So this proves the impact of using a data-driven system model in daily production planning. So next, this is for the recommendation for NVC company. Based on the optimization result, we would like to give several recommendations for NVC to enhance their production planning and overall efficiency. The first one is maintain a reliability in fulfilling customer contract. Ensuring consistent and timely delivery will strengthen customer trust and help NVC maintain long-term business relationship. Second one is use linear programming for monthly planning. Applying this method on a monthly scale will improve forecasting, resource allocation, and profitability consistency over time. And the third one is focus on high-value product or dressed timber and pulp. This product contributes significantly to revenue. Prioritizing them in production planning will help increase profit margins. And the fourth is optimize log distribution daily based on model. So by referring to the model suggestion, NVC can make more accurate decision each day to improve operational efficiency and meet production target. So that's for strategy if implement will help NVC maximize profit, improve productivity, and maintain a competitive edge in industry.
So that's all our presentation from our big project system modeling 2025. Hope it will clear and give you a lot of information that you need. So thank you so much. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon.